where's this power? Where's his power down here?
Well, I think I'll be okay even if I don't.
What's your battery look like? Oh yeah, you got it pretty full.
Yeah, I think it's
Okay.
try audio enough. Okay.
Is that playing?
Yeah, it's playing.
You should be using Linux. It works so much better. Actually, depending on what you're doing.
Fresh water here?
Pistols and Thin Lizzy singing A Merry Jingle. That'll be followed by the Ramones with Merry Christmas.
Okay, good. There you go.
Yeah, I think so.
Thanks for your patience with this. I've known Andy Yoder for a long time. And, yes? Okay, I'm just going to set up the video. Greetings and thanks for coming to HopeX. There's this talk, Shortwave, Pirate Radio, and Oddities of the Spectrum, is, I think, in line with some of the other stuff at Hope, because we cover the oddities that you're just not going to hear at any other conference. I've known Andy Yoder for a long time. He's written several books about shortwave pirate radio, and is just an overall really nice guy, and is extremely knowledgeable about this topic. And I'm really pleased that he came to HopeX. He came to Hope 10 years ago, and I finally, after many years, all the planets lined up for him to come. So I want to introduce my friend, Andy Yoder.
Thanks. I guess the first question that I have is how many people listen to shortwave radio or have really listened to shortwave radio? Okay, a good many, more than I thought, and maybe a little bit more than I planned for. I have this is kind of a basic presentation on shortwave pirate radio, and hopefully for those of you who maybe have listened to a lot of shortwave or a lot of pirates in the past, will bear with it, and it won't be too much information that you already know about. So, of course, my goal with this presentation is to educate you about a topic that I've been interested in and that I find fascinating, and try to be at least a little bit entertaining. But really, I hate public speaking, and my real goal is just to get through this without winding up on a YouTube Ultimate Fails compilation. So, I thought the best way to start with a talk on pirate radio would be to start with what got me interested in the topic to begin with. And I did a test run on this presentation last night, and my wife and daughter said that I need to let you know that I have clips and stuff coming, and that it's not just some experiences from when I was like 13 years old. But my first encounter with pirate radio occurred when I was 13. My mom took me to the brand new mall for my birthday, and it was the first one in the area, so it was like a new big thing. While looking through the magazines at Walden's, I found one of the last issues of S9 before they went belly up. S9 was a CB magazine that took off during the trucker craze of the 70s, and it was on its death throes when everyone had finally gotten tired of saying good buddy and talking about Smokies. They cut much of its CB material in an effort to stay afloat by that point. Among the new material was a column on shortwave pirate radio. I saw radio cards from pirate stations around the United States and read about stations like the Voice of the Pyramids, Radio Indiana, and KRKY. And stuff that I just I wouldn't have expected would have existed, because I just assumed that you throw a station on the air and start broadcasting, and somebody's going to show up at your door to close you down. But that wasn't quite the case. So I love the idea that these mystery stations were on the air in spite of the government agents that were out there trying to close them down. One of my best friends got a Hallicrafters SX28A receiver, and that was a 65-pound tube radio. It was used on Navy ships and in FCC monitoring stations during World War II. We sit around in his basement and listen to international broadcasters and talk about pirate radio stations. I had a Zenith AM FM radio, and it was just one of the ones like a tabletop that you would have in your kitchen. But I was impatient to hear shortwave on my own radio. I don't know where I read this, but I read somewhere that radio tuning was controlled by the capacitance of the tuning capacitor. So I thought maybe if I could just change the value of the capacitor, that I could get shortwave stations on my AM radio, which again sounds dumb, but here's my warning. Do not do this. Do not try this at home. Basically, this was this is so stupid it might just work scenario. And I jammed a screwdriver blade into different areas of the tuning capacitor. So more than once I hit the wrong wire and shot blue sparks across the floor. But when I hit the right place, I could hear international broadcasters mixed in with AM stations. And then when I hit a different place, it was just shortwave stations. But I didn't have a good way to hold the screwdriver in place, so I just kind of held it. So I'd listen late at night with an antenna wire in my mouth, and because I didn't have a good antenna, so I was using myself as an antenna, trying to get the best signal while holding the screwdriver in place. With this health hazard shortwave system, I heard Radio Moscow and the Voice of America, BBC, Voice of Nigeria, Radio Peking, and many more legal stations. But I still hadn't heard any pirates. Eventually, I saved up enough money to get my own receiver, and I was able to start seriously listening. It took a few months of checking around the bands and getting my bearings on things, but when I heard my first pirate, WRAM, in 1983, it was pretty exciting. The second pirate that I heard was Radio Clandestine. They were a station with a big signal that they were kind of a professional-sounding underground 70s rock station. Radio Clandestine claimed to be broadcasting from aboard a ship in international waters. They had a big signal in North America, and they liked to transmit hour-long shows right after a licensed shortwave station would sign off. So it meshed right in with all of the licensed international stations, and it surprised a lot of listeners because they thought they were listening to, maybe Radio Prague or something, and here it was Radio Clandestine. So I have an audio clip of Radio Clandestine, and here is a letter from the station that I received back in '83. And I need to get this at the right place.
This is R.F. Burns for the staff and management of Radio Clandestine. We now dig into our files for the utmost in musical enjoyment for you, our valued shortwave listeners. And we feature this artist for this hour from your bootleg radio station, Radio Clandestine.
Another of the first pirates that I heard was KPRC, and they operated on 1616 kilohertz, just above the AM dial at the time. It's since changed, and now the top would be more like 1710. KPRC broadcast a talk show format with liberal politics and lots of call-ins through a variety of telco loop numbers, which I'm sure would interest a lot of the people here at Hope. KPRC was raided by the FCC in the spring of 1984. At that time, it was discovered that the pirate was operating from the facilities of WOZI, WOZW, which was a licensed station in Monticello, Maine. What would happen was the station personnel would shut down the station for the night at midnight, and then they would connect a World War II era military surplus BC-610 transmitter to the station's antenna, and would broadcast an hour or two per month, a broadcast or two per month. Often the shows would run maybe 4 hours, and they would do that after they would sign the licensed station off for the night. Unfortunately, I do have some audio from KPRC that I recorded, but the signals weren't too good because I'm from Western Pennsylvania, and the signal from the very tip of Maine wasn't great into Western PA. But I have a different station that also broadcast from right around the same time, a station that I heard a little bit later called WDX, and they were thought to be from the New York City area, and they also featured a lot of telephone call-ins by Telco Loop. And this is WDX from, this was from January of 1984.
Ontario, Canada, North Carolina, from Cape Cod to Western Ohio, WGX serves the entertainment and informational needs of listeners everywhere. 1620 is the place to be for music on Live Mike with Pirate Mike and Pirates of the Caribbean with Pirate Jack. At midnight, listeners are invited to participate on the WDX Pirate Line, the call-in show which lets our audience express their feelings and opinions on any topic. If you would like to to us for information or a QSL card, send a self-addressed stamped envelope to WDX Radio.
And that was a recording that I made just on a boombox with the loop antenna inside. It wasn't any special radio system. So as you can see, they had really a pretty good signal into Western Pennsylvania at that time.
After the talk.
Again, for me, it was really cool to hear these stations. I would, after like a late night of listening to them, I would excitedly tell my friends the next day about all the stuff that I heard, and wondering what was going on behind the scenes of all this. And even, that's the thing, even when the programming wasn't exciting at the moment, like I think that these two clips were kind of entertaining, but you never knew what would happen next, even if the station really wasn't that exciting. And I found that aspect to be both exciting and refreshing. And a lot of stuff has changed technologically and otherwise in the past 30 years, but this aspect of pirate radio has really kept me fascinated with the hobby the whole time. Okay, so this presentation isn't just on pirate radio, but also on some oddities of the spectrum. So if you haven't heard shortwave, you won't really know what's an oddity and what's normal. So let's go back in time about 80 more years before this, and everything will get blurry or wavy, and when it gets back in focus, you'll know you're there. What is often considered to be the first broadcast was by Reginald Fessenden in 1906, and he put a little broadcast on the air of just a few different things, like a song that he played off of a record, and some things like that. But in the next 15 years from that point, a number of amateur radio operators from around the country were experimenting with broadcasting, both music and community news, just for their little hometown area. At the same time, the Navy was also very interested in radio. And if you know anything about the Titanic, you'll understand why the Navy wanted a large amount of spectrum space and transmitters on every ship. By the 1920s, radio broadcasting exploded. For example, on March 10th of 1922, there were 67 broadcasting stations, and by 1926, there were 536. So it just exploded, kind of like how the internet has taken off from 1994 to 1998. One problem with everything was that in the early days, no one had yet developed vacuum tube oscillators, and the result was that stations could only transmit on a small chunk of low frequencies. Another problem was that transmitters at the time were not exactly filtered, and receivers were not exactly selective. The result was that one station on the air might occupy about a third of the broadcast band. So you can imagine what that would be like in a place like New York City. It's one thing if it was in the middle of Iowa, there might only be 2 stations on the air, and it wasn't hard for the stations to not cause interference with each other, but along the coast especially, the bands were a mess. So by the 1920s, radio listening had become a hobby, somewhat like a high-tech version of stamp collecting. and people across the country stayed up late at night trying to hear as many stations as possible and writing for radio stamps and cards from the stations. It was such a fad that even movie stars participated in contests to hear the most difficult stations, which is kind of hard to imagine now, and it makes me try to think of a modern-day radio listening contest with Katy Perry and Miley Cyrus trying to battle each other for who could hear the most difficult station. The radio listening hobby, which is called DXing because DX was a radio abbreviation for distance, also brought about pirates. Although unlicensed broadcasts occurred back to the days of Fessenden, the first pirate broadcast that I found documented was from 1925. I found a newspaper that described how during one of these contests, some pirate in the Midwest broadcast music and used a fake English accent and the call sign of an English station. The article said that hundreds of people were fooled into thinking that they'd heard their first transatlantic station, and apparently a lot of people were not amused by that. So now to jump ahead a little bit so that I don't spend all my time on radio history. In the early days, the Navy wanted transmitters on every ship, the public wanted entertainment, and amateurs wanted to experiment. All were fighting over just a limited amount of space, and they were all interfering with each other. So the bands just sound like a mess of Morse code from both Navy and amateur stations, and that was all mixed in with music. The radio spectrum began to be regulated at that point. The Navy and the broadcasters took the prime frequencies, and the amateurs were given the worthless frequencies above the AM band. The only thing is that this range was actually usable for longer distances than those that the Navy took, or the AM broadcast band for that matter. Everyone eventually figured out that the amateur frequencies, called shortwave at the time, were extremely valuable. Before long, this huge swath of radio spectrum was subdivided into different bands, and some of these bands were used for shortwave broadcasting, some for amateur radio, some for military communications, some for aeronautical beacons, and then above the CB band there was a section that was dedicated to diathermy equipment. So there's a lot of different weird things that were placed onto shortwave. So the first digital mode was Morse code, and that dated back to the days of the telegraph. But in the 1920s, radio experimenters had invented different methods of transmitting television and also fax. A lot of people think that television went back to just the 1950s, like maybe 1950, but actually regular TV broadcasting went back to 1939, and before that they were experimenting with TV as early as the late 20s. And early fax was transmitted by radio. Usually you just think of it as by telephone. And one of the concepts behind fax was that people would be able to get their newspapers by fax, that they would set their radio to a certain frequency and then turn on their newspaper printer and go to bed that night and wake up in the morning and have a newspaper. But unfortunately, it wasn't so much the technology that was a problem, but more the how do you work that out with revenue for newspapers. So now it seems like as good a time as any to play a few audio clips from different digital modes and different just kind of odd things you might find across the band. This small selection of clips isn't comprehensive at all, but this week I was spinning through the dials and I recorded a few segments as I passed through. And also I found a couple of things while I was digging for some of this archive audio, like from WDX. So this is Scrambled Voice, and this is military of some sort, probably U.S. Oh, that's not a lot of fun to listen to at that volume. Here's some radio teletype, and for the next couple here, radio well, I don't know about Link 11, but that and Stanag 4285, whenever they imagine whenever you're watching a TV show and they're talking about typing something and they show something typing or somebody typing on the screen. This is about how fast the radio teletype and STANAG 4285 come through. They're just different systems of delivering simple messages. And this is radio teletype. And this is link 11. From everything I've read, this is used by NATO. Okay, I'm not sure who all uses STANAG 4285, but I've seen some of the decodes were from French Navy ships, basically just telling basic stuff about their coordinates and things like that. Okay, here's some airport communications, just a little sample. This was on about a week ago. This was from, once my cursor comes back, this was from an airport in Newfoundland.
Bravo, Kilo from Animal 0. Roger, that is what I'm sending. I'll try another double.
What is that tone at the end?
Actually, I don't know, because for most of these, I mean, I kind of have an interest in this a little bit, but for most of these are the noise sources that I hear on the band that I'm avoiding so that I can listen to pirates. So I don't pay as much attention to them as some people, and there are some sites that really get into what all the datas are. Okay, those were really pretty much normal stations. Some kind of strange stations. One is Yosemite Sam, at least that's what it's been called. The three over on the right-hand column down, not SSTV, but the other three, those are all mystery stations that nobody really knows what they are, what they're for. There are some theories about them, but these are the strange stations. Yosemite Sam, it was on for just a little while for like 24 hours a day, and it was a repeating clip of Yosemite Sam from a clip of him from the cartoon Bunker Hill Bunny, and then there's data in between, and this is what it sounded like. Okay, the next one was a lot the same, except there wasn't a data burst in it. And I tuned through when there was not quite a contest, but it was an International Pirate Radio Day. And so pirate stations from around the world were broadcasting and hoping that people from around the world would tune in. And there were stations in Europe that were heard in India for the first time, and a lot of different places like that. And there's some shortwave listeners who don't necessarily listen to pirates a whole lot, but they're like, oh, hey, there's a pirate thing going on, so I'm just going to tune in. So this was down nearby, but not too far from where some of these stations were on the air. So I don't know if it was a pirate station that was putting something on that sounded kind of like Yosemite Sam, or if maybe if it was a military station or what, but it broadcast this message, and then it had 20 seconds of dead air, and then it repeated the message again, and it went on I heard it for about 5 hours, so I don't know exactly how long it it did this, but it was on for a while.
Got your dark suit, greasy water all year. Don't ask you to carry an oily rag like that. They use an aggressive policeman to flag thoughtless motorists.
And what he's saying is, get your dark suit and greasy wash water all year. Don't ask me to carry an annoying rag like that. I use an aggressive policeman to flag thoughtless motorists. So it doesn't really sound like much anything, but if you do a search on these are phrases that are used to pick up different dialects from around the United States. And that I didn't realize that there were set phrases to pick up different dialects, but that's what they're used for. So these are linguistic tools, and why somebody would transmit them over and over and over again on shortwave, I have no idea. So I guess that's part of the mystery. And the next one is Backwards Music Station, and it's another digital, digitally encrypted format of some sort. I guess it's data, but I don't know if it could be something else or not. You know, I don't know if there's voice in it or anything else, but it sounds like this. I had that a little longer than I should have. But some people also call that a whale call station for obvious reasons. And a lot of people were kind of interested in that one just because it's so weird. That's why I recorded it to begin with. I recorded that one about 4 years ago. I think it was broadcasting or transmitting on the edge of where a lot of the pirates broadcast. So I tuned across and was like, I might as well record that because it's so weird. And now the last one here is slow scan television, SSTV, and there's my cursor. And that's one sound that I know very well because it's not actually TV. It's more like just like JPEGs for radio. So you can actually transmit JPEGs on the radio, and so obviously it's a really popular one with pirates because they can broadcast a program and then put on their station logo either before or after the show. So that one was from Wolverine Radio, which is a pirate, and I have an image of the SSTV from Wolverine Radio right there. So, getting back to the 20s and 30s, most pirates at that time were, aside from that hoax station, were unlicensed AM band stations that were broadcasting from a town like a regular station. A lot of times they were on from maybe really small towns, and either they couldn't get a license or they were maybe doing it because they didn't like the government interference and were just like, well, I can put a radio station on the air, so I will. And they tried to hide the fact that they were unlicensed, and a lot of times they were operated by local businesses. So they just sounded like a regular radio station. Probably most of the people assumed that they were a licensed radio station. I've seen some reports of stations like that were broadcasting from coal mines. So they were just a local station. One exception to this was WUMS, which started in 1925, and they sometimes went by the slogan, "We're unlicensed mystery station." So obviously that was very different from those other stations. Station operator Dave Thomas, not the Wendy's Dave Thomas, he had emergency flood broadcast warnings from near the Ohio River because he lived right at the Ohio River. So he was trying to do some community service work on a kind of temporary basis. And he also aired tests specifically for shortwave hobbyists. Thomas sometimes provided advance notice for his tests, and his operations weren't exactly a secret. After a while, his broadcasts caught the attention of the FCC, which regulates communications in the United States. 1930s radio technology was not exactly mobile, so he didn't have a way to just drive around in his car and broadcast or anything like that. And here is a picture. Oops. Oh, here's WUMS. This is a radio card from WUMS. This one is from 1948. So this was near the end of the station's regular broadcasting career. And this is some transmitting equipment from an amateur radio station in the late 1920s. And yeah, it became more miniaturized by the 1930s, but still most ham stations at that time, you would have been looking about this much equipment, and it would have been heavy and really unwieldy for just taking on a backpack or anything like that. Oh, okay. Let's see. The bottom part is a desk. Up at the top, you can see a couple of lights. So that box at the top, that's probably about this big. So, and you can see some like 8x11 plaques in the upper left-hand corner. So it's probably hundreds of pounds of equipment at least right there. Dave Thomas had to try to avoid the FCC, even though he was broadcasting like that. So I haven't found. Okay, I should say the rumor is that he had built a transmitter into a large table, and I don't know if the power to the transmitter or the antenna led through the antenna legs, or through the table legs. But I'm assuming that they both led through separate legs, and when the FCC would arrive, he would bump the table out of place and knock the transmitter off the air. And then the FCC would come in and look around for the transmitter and couldn't find anything because the whole time it was in the table. That probably wouldn't fool too many FCC agents now, but it was pretty clever about 85 years ago. And I also wonder about how the connections were, if that's actually how it was done, because if he had AC power hot on the floor like that, I can't imagine that he would have mopped his floor too often. He wound up going to civil court a few times before 1950, but he got away on technicalities each time. Okay, next. Here is RXKR. And in the 1930s, another station caught the attention of the FCC and of the other broadcasters. RXKR took advantage of loopholes in the rules, and they put a transmitter on a ship, the city of Panama, and it was licensed to the country of Panama. And the idea was that if they were licensed to a different station, then the U.S. couldn't interfere with them. They sailed out into international waters every morning from the coast of California to outside into international waters. Okay, I said that. Because the boat was also a floating speakeasy and casino, the U.S. State Department pressured Panama to revoke the registry of the ship. As soon as Panama complied, the ship was towed into custody by U.S. authorities, and that was the end of the station. Part of the pressure for the station to go off the air was they were broadcasting with 500 watts at that time on 815 kilohertz, and they were really interfering with stations from Los Angeles on either side of them. And stations complained to them and to the FCC, and they said that they would move to a different frequency for, I believe it was $10,000. So they had some other things kind of going on there too. The 1930s gave way to World War II, and in one sense, these were not good years for pirate radio, and they were not good years for a lot of other people too. The war consumed everything. The amateur radio band in the United States was closed down. I'm not sure if it's closed down everywhere, but it was in the United States. And many amateurs became radio operators in the military. Plenty of illicit stations were on the air from Europe, but these were clandestine stations, which might be somewhat of a synonym for underground or pirate to most people, but in the radio sense, radio terminology, clandestine only means that stations that are operated by an opposing government or military group with the intention of demoralizing or overthrowing the target. Just a few of the stations, the World War II clandestines, included the New British Broadcasting Station, Gustav Siegfried Eins, Radio Caledonia, and Radio Atlantic. And although some of these stations claim to be broadcasting from either England or Germany by a little underground group that was, somehow rallying against the authorities, they were almost all operated by the big government stations. So in England, they had a special group to broadcast to Germany with a whole bunch of different stations. And the same thing for Germany. So this is one of the Nazi systems. This was the Ziesen transmitter or antenna farm near Berlin. So some of these stations were being broadcast to England from places like this. They weren't at all like somebody running around in a van broadcasting or anything. Famous underground groups, such as the French, Dutch, and Polish, transmitted coded messages either to each other or to England. You've seen all that kind of stuff in the movies. But they didn't broadcast programming. World War II required fast-moving armies, intelligence, and communications over long distances. The war greatly advanced the miniaturization and portability of electronics, and on the other hand, it also sharpened the FCC's abilities to direction find radio stations, because the FCC had a huge network going on in the U.S., and they were able to track down some German spies that were feeding back information from here. And here is just a snapshot from someone in the German army looking at one of their field communication radio stations in the field. One of them is a receiver, the other one's a transmitter. They work together, and the antenna is on top. And as you can see, the equipment here really has been miniaturized, and it's not small. You're not going to hide it in your pocket, but you're also you will be able to just pick it up. You can see the handles on it, and two guys could carry it around and transmit. And that kind of led into the next era. And although I don't know of any pirates who operated during World War II, one of the key points of this discussion is that shortwave radio is sometimes dismissed by government budget cutters as just a quaint, obsolete medium. And pirates have been dismissed for years as kids playing radio. But if you read the personal accounts of World War II or watch movies, one of the key things that comes up is broadcasting, and it's usually by the BBC. The BBC was the lifeblood of freedom at that time for people in Europe and around the world, and people risked their lives many times to hear the BBC. So even though the Axis controlled the skies of Europe, along with the governments, the press, the roads, the seas, they couldn't stop shortwave radio signals from entering their territory. And they did try. Today, the internet is the information highway. More music, newspapers, magazines, and opinions can be found on the internet than have ever been published in any given year. But with just a click of a button, sites can be removed or blocked, postings can be traced, and posters can be jailed. If you travel to North Korea, you won't be accessing the internet or your smartphone. You won't be accessing any unrestricted media unless you own a shortwave radio, because Kim Jong-un can stop anything from happening in his country, except he can't stop Dennis Rodman from making a fool of himself, and he can't stop shortwave signals. I'm not saying that shortwave radio or pirate radio makes a healthy democracy, but I do feel that it's a component of one. So going back to World War II, the directions of pirate radio went in the next era are difficult to explain. In Holland, it exploded. Starting in the 50s, dozens of pirates sprung up using abandoned and surplus U.S. military transmitters from the war. These stations were often operating relatively in the open with the support of their town. And I've heard stories about these stations. They would set up a big tent in their town and bring the transmitter out, and they would play polka music, and the whole town would dance around while they drank beer and did pirate broadcasting, which sounds kind of strange. Here is a BC 610 transmitter, the kind that KPRC used. This one wasn't used by a pirate, but it is one that was left behind in Europe, and it was used by, or it is being used by, an amateur radio operator in Europe. And in the United States and Canada, it's been nearly impossible to find a mention of pirate radio in the 50s. Instead, the roots of modern-day North American pirate radio seems to be the little kit transmitters that were used to relay the record player to the hi-fi set. These were called phono oscillators, or sometimes home broadcasters, and it seems like most of our 60s and 70s pirates got their start from these kits. And this is station KOS from Cleveland from 1966. These guys have graduated up from those little kits. They have a really pretty nice setup here, especially for 1966, with the dual turntables. They've got other equipment in the back that I can't see what it is, and a reel-to-reel. No, I think there are two reel-to-reels back there. So these guys had moved along pretty well, and this was pretty advanced in the United States for 1966. In the British Isles, on the other hand, and in other parts of Europe, the next step was commercial, high-budget, ship-based broadcasting from international waters. This is well documented, and you might have even seen a movie or other things about it. This is Radio Nordsee International card from the station, and they were broadcasting pretty much in the early 70s, and they were on shortwave. You can see the big shortwave mast in the center of the boat, and the FM, I think FM transmitters on either side, or FM antennas, sorry, on either side of that. The ship was painted, if you notice across the sides, it was painted all different colors, and between the colors and the mast, there was no questioning that this was not just a freighter hauling some stuff somewhere. This was a pirate broadcast station that was playing lots of new music for Europe.
That's also a dazzle ship configuration.
Excuse me?
Are you familiar with the dazzle ships of World War II?
Oh, okay.
It's harder to spot a ship painted like that on the horizon.
Okay. So these guys went off by the mid-70s, and by the early 70s, by the mid-70s, the European laws drove the potential offshore stations onto land, and the North American kids who were playing with the phono oscillators discovered underground music, politics, and higher powered transmitters, and the Dutch kept on broadcasting polkas and rock music to their friends and neighbors. And everyone lived happily ever after. The past 40 years of pirate radio are the modern era, and plenty of names have changed, but a lot of everything else has remained the same. So I'll try to address some more about the specifics of the operations and the equipment and everything in this section. I think the best way to get a grasp on how a pirate operates is to think theoretically about a new station. Like if someone today would be thinking, I want to start broadcasting, what would be the first thing that he would do? First would probably be the band of operations, AM, FM, or shortwave. FM is most popular, but the FCC polices it the most. The coverage area is the smallest, and it's the easiest to trace. So there are an awful lot of FM stations that go on the air and wind up getting fined, and so it's not necessarily the best place for pirates to operate. Especially because these days I'm not sure how many people actually tune their radios. It seems like most people know what's on a specific frequency and they hit their auto select and the radio's there and that's it. So with the AM band, it has the fidelity of shortwave, but it's overcrowded at night. So it's really limited. It kind of has the worst of both, the worst aspects of FM and shortwave. I'll talk about shortwave because that's what this presentation is about anyway. The main question then for a pirate is what transmitter to use, because the transmitter is what makes someone a broadcaster and not just a program producer or a webcaster. The main choices here are the amateur radio transceiver, the amateur radio transmitter, or the homemade transmitter. And here is a modern or relatively modern amateur radio transceiver. This is an ICOM IC746 Pro. And let's see, transceivers like this one are popular because they work as a full coverage receiver, so you can tune around and hear all of the shortwave dials or frequencies, and they can also transmit on the amateur frequencies. But with the snip of a diode, most transceivers can transmit anywhere from the AM band up through the top of the shortwave. So they're popular for that reason. And this particular IC746 Pro has a lot of features, so it's more expensive, and more in the $1,000 to $1,500 range used. Transceivers are also popular because nearly all of them will operate from either AC or battery DC power, so they can be used portably. Some cheaper transceivers are the Kenwood TS440, the Yaesu FT747, the ICOM IC735, and these are often more like $300 to $400 used. You can find a lot of these on eBay, and some of the ones that I've seen on eBay have already had the diode snipped so they can transmit anywhere. The next one is an old transmitter. This is a Heathkit Apache, and this was a Heathkit produced a lot of different kits, and so you could build them yourselves. And this one is this would have been quite the project to build it yourself. It's from the late 50s through sometime in the early 60s, and it has a sort of vintage car appeal with the chrome and everything. And I'm not sure how much they weigh, but I think they're about 90 to 110 pounds. And there's a lot of steel in them. So like an old car, they also require some work replacing age-vulnerable parts before they can operate reliably. And especially with a transmitter like the Apache, which could be bought in kit form, and you don't really know if it was maybe a 13-year-old building it without a whole lot of knowledge, or somebody who was an electronics expert. So even buying a transmitter like this particular one, not all of them, but this particular one, there are a lot of questions that would arise. But with a few modifications, a transmitter like this will sound as good or even better than a local AM station. But they're really heavy, and they limit mobility. So probably some stations have operated by taking a generator out and running it off a generator from somewhere, but that's pretty loud, and that attracts attention. Depending on the condition and the operability, a transmitter like the Apache, the Heath DX100, the Johnson Viking Valiant, or the Johnson Viking Ranger, they'll often sell for anywhere from $100 to $1,200. And the next general category is the homemade transmitter. People build their own transmitters for a variety of reasons. Of course, one is just for the experience and to learn more about electronics. And a lot of the people, there are a number of people who get into pirate radio just because they're interested in building their own station and they like to play around with the electronics. Another important reason is to be able to have inexpensive, low-powered equipment that can be operated from battery power. A transmitter like the one shown in the photo could be placed in a woodsy area or a state park or some place like that that's kind of a no man's land where people frequently go, so it's not unusual for someone to be there. And they could be transmitting for an extended period of time without the operator being anywhere near the transmitter. So that means that the government agents if they would decide to go after the station, would only get the transmitter and the antenna and maybe an iPod or some other audio source, and they would not be wind up finding the operator. The transmitter shown in this photo is a little 1.1 watt Corset, and this is built into an Altoids can. So it is really tiny. And I've heard, I believe that I've heard this particular transmitter from hundreds of miles away. So they don't necessarily get out that well. That's, I think, a better than the normal result, but still the possibilities are there. Primarily in countries that don't have much enforcement, pirates build their own equipment so they can get more power. Station operators in Serbia, Greece, and Holland are notorious for building huge multi-kilowatt transmitters. A number of stations run 5, 10, or more kilowatts. Some of these are really interesting MacGyver-looking setups. One of the ones that I've seen photos of, the transmitter was built into an old microwave, and its power supply was built into a tower computer case. I saw one, or I've talked to one person who went to visited a station broadcasting in Scotland, and he had sections of the high-power transmitter everywhere, and there were wires running down overhead, and his friend came through and said, "Well, what happens if I touch those wires?" And he said, "Don't do that, you'll die." So, some of these homemade transmitters, there's some other things that make them interesting. And then there's other less used reason is to operate in a different mode. The operator of XFM, which is a current station, built his own transmitter so that he can broadcast in Sequam stereo. And he broadcasts in Sequam stereo on shortwave, and it sounds great on receivers that can decode it. There are some receivers now, the SDR, software-defined radios, that can decode Sequam stereo, and it sounds great. Here's a really common type of antenna that's used by pirates. This is an inverted V. It consists of 2 wire legs that run down from either side that are cut to match a frequency. The center support could be a mast like this one, or it could be a tree or something else handy. This particular one is an image from Radio Lowland in Holland, and evidently they don't mind if everyone from blocks away can see their antenna and see that this is a radio station, but most of the people who use an antenna like this will have them better camouflaged, like in woods or someplace like that. And quick, because I'm running out of time, here's a propagational map of a station, and this kind of shows how far the way that shortwave operates, that it creates kind of a donut-like pattern. The smallest range is during the around noon, and then it expands until nighttime, and you can see that a station, the signal can spread out into Europe, into down into Mexico and beyond. So that's the kind of propagation you could expect with shortwave. And I'm running out of time here. I've been kind of trying to compress too much.
So a couple minutes of Q&A, you can do that, or you can just do that outside too. We got a couple more minutes left.
Okay. Well, I got a little bit to add. Let's see, I've just skimmed the surface of this. So I posted a page of links with more background information on my blog, and that's the URL. Some of the links that I have up right now are pirate radio forums that you can check out. They have a lot of loggings as they happen. Radio magazine, links to some weird shortwave stations, background information on the Hallicrafters SX28 receiver, background on the SCR 299 transmitting truck, a shortwave equipment dealer, and let's see, a page of schematics, photos, and parts layouts for Dave Martin's Corsair and Corset transmitters. That was the little one in the Altoids box, and more links that I might add over the weekend as I think of them. So
Thanks very much, Andy. Before the room here, Andy's going to be sitting here. He's got a few copies left of his latest Pirate Radio book, Pirate Radio Annual. I own a copy. It's great. I recommend it. So he'll be outside a few minutes, right outside here at the table to answer any questions. And if you want to buy one of his books, he might even sign it for you. Thanks. We've got to make room for the next guy.
Yeah.
Can you do the questions outside? We're going to clean up here. Good job.
Well, that's easy enough to get.
Sorry to rush you off stage.
Oh, no.
You did great.
Oh, thanks.
I had several people say, this is great, you should come talk.
Can you do a quick thing audio for us?
It has to pre-render before I can really go through it quickly, but I can try. But I'm showing everyone all my slides. Whoops. Here, hold on. I'll not have it pre-render. Audio. How about just some music?
Okay.
Hi, everyone. I'm Nadia Peak. I'm going to speak for the next hour, so if you didn't want to listen to me speak, you're in the wrong room. I'm a PhD student at MIT in the Center for Bits and Atoms. I work on machine control systems and machine design. And I'm going to be talking about machine design as a form of dissent. I don't know, I'm going to start with like a short story. I don't know if any of you guys remember, hello? I don't know if any of you guys remember this red balloon challenge. DARPA released it in 2009. There were 10 red weather balloons that they kind of put out throughout the United States and said, whatever team is able to find all the locations of all of the balloons is going to win $40,000. And I thought it was a really thinly veiled attempt to try to gather information about how public might use social media for dissent. And I thought it was stupid that taxpayer money was paying for it, and I thought a lot of the things about it I thought were really problematic. Red balloon searching, and so we decided that we're going to hack the competition by putting up fake red weather balloons. I happen actually, so some of the research at MIT is funded by DARPA, including mine, and so I happen to have a lot of DARPA paraphernalia, so I can pretty justifiably pull off DARPA impersonator. And on the right is Jeff Warren from Public Lab, and they do balloon mapping with red weather balloons, so we actually also had a big supply of big red weather balloons that we could put up all over the place. And I work in this really quite well-equipped laboratory where we have we call them input and output devices across length scales. So we have laser scanners, water jet cutters, we have CT scanners, AFM lasers, and a whole bunch of fabrication equipment. And so making the little flag balloon things that we could put up to impersonate the red balloon challenge was really relatively trivial. It took us about 5 minutes of fabrication and a little bit of helium. And the kind of tools that we have access to, because we're a research organization that works on fabrication, is really quite astounding. We have all this stuff that we can do DNA folding with. You know, some of the stuff that came out of our labs includes e-ink, or that annoying sensor that beeps at you if you don't buckle your seatbelt, and I kind of feel like us being able to make something to be able to subvert a narrative about DARPA is something that everyone should be able to do, because we really had a lot of fun doing it. And so using the tools in our lab, we teach a class called How to Make Almost Anything. I don't know if any of you guys have heard of my advisor, Neil Gershenfeld, but How to Make Almost Anything takes you through making everything from electronics to large format like furniture or houses, using these tools that we have access to. And we don't actually stipulate that anyone has to do whatever they can do whatever they want with the tools. And so people end up making all these very useful things like web browsers for their parrots, or alarm clocks that you have to wrestle with, or really personal projects that have nothing to do with business models or economics or products that are aimed for mass manufacturing. And so digital fabrication, as defined as using a computer to control a fabrication device, making it easy for you to just alter some code and then remake something in a different way. It's really quite a powerful technology. But I'm going to go back in history a little bit to think about where this maybe all came from and how history might inform how we might use it going forward. So I'm pretty sure none of you remember the Industrial Revolution. But when it started, one of the things that was really exciting about it was people were able to get products because products were becoming cheaper, because manufacturing was becoming easier, and we had all of these distribution networks where people could buy things because factories could ship goods through the railroad system or through the road system to different places. And we got automobiles, which also enabled personal mobility, and a lot of the impetus for developing better fabrication tools kind of came from the war. There was a big need for precision manufacturing of things so that you can make things like missile nose cones, really nice stuff that everyone loves working on. And that kind of confluence of scientific and engineering efforts was extremely strong during the war, and as soon as the war was over, the question kind of became, what is it that we're going to focus on now as scientists and technologists? And I don't think that any of if anyone wants to go over there. So so after the war was over, the it's kind of distracting. It was kind of difficult for different kinds of people to work on, or to figure out what we're collectively going to be working on next. If there isn't imminent threat of global destruction, then how are you going to work together on the next thing? But continued making tools for fabrication, and a lot of the tools that were being developed were still very strongly grounded in kind of a military application. So making more consumer cars, but still with strong analogy to military vehicles, to making flight, and so automation was is something that was really taking the Western world by storm, and enabling the mass production of many devices, using economies of scale to be able to give people cheap products, but those products weren't necessarily the kinds of things that at least someone maybe like me would want to see on the market. So I have a short video to show you so that we can think about automation. That's from BuzzFeed. I guess if you think about that video, all the things that you just saw and all the machines that you just saw doing things, so making glass jars or making car suspension springs or making pretzels, those are all custom machines designed specifically for the purpose of making that particular thing. So if you're the kind of person that makes millions of pretzels a day, then you have enough money to invest in automation to make a machine that's going to make millions of pretzels a day much faster for you. Back in 1955 or 1954, arguably, MIT kind of stole the idea of an independent inventor and hooked up a milling machine to a computer. And the capability that the computer therefore has is you can change the code easily and not necessarily use a general purpose machine to make different kinds of objects without necessarily needing to reconfigure your machine for different kinds of tooling. And that's pretty exciting, not just because you can make lots of different kinds of stuff, but because you have access to precision manufacturing, which you need to be able to make more precision manufacturing, for example, more precision manufacturing tools, for example, but also any kind of analytical instrumentation or different kinds of machine tools. You're going to have to need a quite high level of tolerance, which is going to take you a long time to figure out how to do by hand, and you might have to put in 10,000 hours to become a master craftsperson, or you can just use a machine that has it programmed into it. And so, in case you guys hadn't already seen what a CNC mill looked like, I included this short video of a Moriseki 5-axis milling machine. I can kind of see you guys. How many of you guys have ever used a CNC machine? Anyone? A bunch of you. Okay, awesome. So this one is pretty sexy machine making a turbine blade, and it has X, Y in the top head, Z in the top head, and then A and B in the rotary aspects. So you see, it's using all degrees of freedom that it has to be able to make this complicated part. And so computer control of machine tools is super awesome. We can make all these complicated things. However, it's not changed a whole lot. I was just at NASA Ames 2 months ago, and this is exactly the same milling machine as is in that photograph from 1957 in Popular Science, and the only thing that they changed about it was they updated the computer at some point, but the equipment itself is still exactly the same. And I guess, having fancy milling machines to mill large pieces of titanium at NASA isn't going to change a whole lot, but it's not necessarily something that people are going to need at a personal level anytime soon. And so, without changing the digital fabrication tools, we're also not necessarily going to change what is going to be made with them. So, how many of you guys frequent hackerspace or makerspace? A bunch of you, yeah, because they're fun. So you can use digital fabrication tools for personal fabrication in places like Fab Labs. So I guess our research group is heavily involved in promoting Fab Labs and helping them run. For example, here's one that's in Vestmannaeyjar in Iceland. It has a full electronics workbench, so you can do hardware hacking. It has a large format milling machine that's only 3 axes, so not as fancy as the Moriseki in that video. It has a laser cutter, so you can cut plastics and woods. It has a small 3D printer. It has a small milling machine for electronics prototyping, and then it has computers for doing digital design and simulation. And this space is kind of nice because people also come in and are able to interact with other experts that are trying to use these machines. However, we found that using the machines was complicated enough that we had to rewrite some of the design and manufacturing internals so that novices could have access to that. More on that in a second. And so, in Fab Labs, even though the machines are maybe not entirely designed for personal fabrication purposes, people are still making interesting things. So Jens Divek, he's working on wooden prosthetic feet prototypes. I don't know if any of you guys saw the Fab5, a wireless mesh network. There was, in the Fab Lab in Jalalabad, Afghanistan, there was one satellite drop. And so to be able to share that internet across all of the NGOs that were spread through the city, they created these parabolic dishes on the 3-axis CNC router, and then modified WRT routers so that they would have a longer wait time before a packet drop, so that they could send internet out to other spaces throughout the city. And that was entirely kind of this is our problem. There's not a market that has this problem intervention. It's another student in my lab who wanted a kayak, and so he made a kayak. So you have all these, you have access to all of this digital fabrication equipment, and you can refactor it to do different things. And obviously something must be really interesting about it, because, for example, in the Fab Lab in Donetsk, I don't know if Kostya is here somewhere over there. So Kostya's Fab Lab in Donetsk was occupied because obviously you can't have people have access to digital fabrication tools because they might just use them for dissent. So 3D printers may be kind of political after all. using all of these tools still kind of sucks. And so that's kind of what I wanted, the crux of what I wanted to get at to talk about today. If you think about just the CNC milling machine that you saw in that video earlier, to be able to write the tool path for that milling machine, you have to use horrible software packages that generally only run on Windows. The controls get exported in G-code, which is not a Turing-complete language. I think that somebody's giving a talk on G-code today, if you want to learn more about G-code. But as far as I'm concerned, we should get rid of G-code. G-code is stupid. And then you have like a really fancy interface where you take a USB stick and you put the G-code that just says go from this coordinate to this coordinate to a machine that has an amazing interface like this. And then you say, there's actually a button that says load tape when you put your USB stick in, because nobody bothered update it since, I don't know. And I guess machinists are also recalcitrant trend types that don't necessarily want you to be changing all of their vocabulary, but it's not great. And then you bring your end mills, and then you show up in the machine shop, and you watch the machine gets to have all the fun. And generally, especially if you're not running the same job over and over again, if something is going to go wrong in your tool path, you want to be there before the entire lab burns down, so you just have to kind of sit there and watch the machine do all of the work. And so if we want to decompose machine tools into what their different parts are, I have this pyramid that I like to talk about, where it's kind of the pyramid of machine control, where you start out with, you have some tool head. So imagine we have a laser cutter, the tool head is a laser, or if we have a milling machine, the tool head is a spindle. And there's a tool head that we want to move around, and to be able to move it around in a constrained fashion, we have some mechanical system that we're placing the tool head on. So maybe it's an XY frame, or maybe it's something that we suspend from the ceiling that we want to move up and down. And so once you have it on that mechanical constraint frame, you have to move it somehow. And so maybe you can move it by hand. You don't need to have automated control, or maybe you need sensors and actuators to move those things around. So the sensors and actuators, like stepper motors or servos, or maybe you're using hydraulics, those things have to be specified as well. And then once you have your tool head, which is on a mechanical system, which is moving around using some kind of actuator, then you're going to have some kind of control system that's going to tell the actuators how to move in response to the sensor input. And the control system could be a PLC. PLC is vulnerable for all kinds of exciting security attacks. Or it could be just a microcontroller, or it could be a single-purpose computer. And then to be able to talk to that control system, you have to have some way that you're going to come up with the commands that you're going to tell it. And so you have applications and interfaces like Mastercam, or the Autodesk 123D suite. And there's kind of on the left, I have the logos of all of the kind of typical industry standard-like things. They're all thousands of dollars. Using them requires hundreds of hours of training, and they're all really quite annoying. And then on the right, there's a bunch of open source alternatives that, while they're not going to be used to run a car factory anytime soon, they're slowly improving. But the problem is, or one of the problems is, that along this pyramid, there's a lot of stratification between the layers. Each layer here is a pretty well-established field, and you're going to have people that know how to do it really well, and then you're going to have people that know how to really do it really well and maybe also want to do it in their free time, and maybe we'll develop an open source alternative. But you don't necessarily have people that are like, oh, I like working on mechanical systems, and I also want to make an application interface for it that's really easy to use. And so going from each layer to the next layer of this pyramid is kind of like a bad party trick of telephone, where you're like, oh, I made this code, and now I'm going to have to try to get it to talk to this machine, and my motors speak this weird protocol, and you end up with really stubborn people like me that like working in this space, but otherwise everyone is kind of like, everything is just kind of a hack. So even if they're incrementally improving, digital fabrication tools are still not that accessible for people who just want to show up and get something done. Because we have finicky bad interfaces. The applications of digital fabrication machines are really quite limited because they're grounded in this military industrial history of what we want CNC equipment for. We want to make really precise metal parts, and we want to make things that are approximately this big, and we want to have the most precision possible. Therefore, we're going to use really expensive materials, most of the fabricators of digital fabrication equipment are you can cluster them into only a few corporations. Like, for example, in the 3D printer space, you have like a wide range of DIY kind of 3D printer people, and then everyone else is pretty much owned by Stratasys or 3D Systems, both of which I would say are pretty evil companies. So, do we really want them to be controlling how we can interface with our fabrication? I kind of disagree with that. So I guess for me, it's then the question is, can we build all of these things ourselves, or at least subvert some of the technology that already exists out there? And so me and a friend of mine, Alain Moyer, spend some time teaching machine design and machine building to people who otherwise don't think that they should be doing machine design and machine building. So this is last week in Spain during the annual Fab Lab conference. We got anyone interested in trying to build a machine in 3 days to come up, learn about different kinds of motion systems, different kinds of mechanical systems, different kinds of control systems. And they came up with a lot of pretty silly ideas for machines. Like this one is like a coffee machine called the Good Morning machine, where you can choose, you can have tea or coffee, it'll give you sugar, it'll give you milk, it'll write your name and like I love you on your coffee. And that's a very useful machine for that person, I'm sure. And so, if prototyping something like this was easier than having to make coffee every morning, then I feel like a lot more people would do it. And so at the conference, we also used machines to make machines. So this is on the right. You can see there's like a folding 3D printer. That's a prototype that was made by Flores, who's from the Fab Lab in Maastricht. And then on the left is a foam core prototype of a machine that is a small-scale version of a bricklaying machine. So imagine you wanted to lay bricks not just in a straight line, but you would want to lay them throughout space however you wanted. So this is a system with 4 pulleys that can extend in different directions. So depending on where within the frame you are, you can lay bricks in different places, which was a pretty ambitious machine to want to prototype in 9 hours, but they got far enough to make a scale model. So here's some more of the machine prototypes that we were building. And I guess one thing that I like to stress about mechanical design is it seems that there's this iteration. Like if you want to write some software, you write a bash script and it takes you like 2 minutes or 1 minute, and if it doesn't work, you change something and then you can try it again, and then eventually your script is going to do what you want it to do. But if you do mechanical design, then you have to prototype the whole thing, and then if you made some big mistake, then you have to change a bunch of stuff, and changing that takes a lot longer than just changing code. And so I guess some people criticize our use of foam core and hot glue because real mechanical engineers obviously only use aluminum and metal. But it's a really easy way to kind of experiment with the different form factors that you might have in your machine. And so I like it a lot. You kind of didn't calculate the tolerances entirely correctly, then you kind of just shove it over and add some glue. Here's a kind of logo turtle-ish machine that these guys built during the conference. And so this was all just 3 days worth of machine prototyping. I think we came up with 6 different machine prototypes, each to do a very specific thing, and we did not only the mechanical aspect, but also the controls and the software and how people might want to interface with the software. So not necessarily making the assumption that the way that you want to use a machine is by standing in front of a laptop and then using it. And so starting to build your own machine solutions is something that I think felt pretty strongly about and hopefully convinced other people during that workshop to do. And so in terms of some machines that I've built, so Lon and I, who taught the workshop, we built this machine at some point, which is a suitcase multi-purpose CNC machine. So it has a milling head. In this photograph, it's milling a circuit board. It also has a 3D print head. It also has a liquid handling head. So if you wanted to do bio experiments, you could do automated bio experiments. And it has like a little scoring and cutting head. And it folds down into this briefcase, so you can take it with you. I've taken it many times as a personal item on a plane, and the TSA never asks me about it. They sometimes They sometimes ask me about, like, I have a space mouse. They ask me about that, but apparently if you make your stuff look like it's very serious, then the TSA is not going to get you in trouble. And so you're... And put a pocket knife in there. Yeah, then they'll suddenly recognize it they'll suddenly recognize it as a weapon. So these are all different machines that I've worked on, kind of experimenting with this different form factor, because it's not just that I'm thinking about machine building as something that you want to have for more custom machines, but also how do you make machines more accessible by making them cheaper and more portable, and more likely to be encountered in a space like a home or a small office, rather than a space that has a workshop like MIT. So here in these photos, there's some small format milling machines for circuit board prototyping. There's like a machine that we made just to draw silly portraits. There's another liquid handling machine for bio purposes, and so. We've been thinking more about how do you decompose machine building into different modules, and so right now I'm working a lot with different reconfigurable modules that you can easily use. So say you need a machine that needs to move in one axis, and you're moving it back and forth, or you need something that moves back and forth and then turns something on and then turns something off. We're making all of these kind of modules that snap together so you could easily prototype different kinds of machines. And again, not just the mechanical prototyping is important, but also the control system. And so instead of using one single microcontroller that interprets G code and sends commands to motors, we're using a networked approach, so that every single node on the network addresses a different part of the machine, and you have a virtual machine on your computer. So say it's a milling machine with 3 axes. The virtual machine says, there's a synchronized move between the X, Y, and Z axes. There's the spindle off and the spindle on, and each of those are different nodes on the network that you can call functions on, as opposed to you just streaming a G code file out of a port and hoping that the G code interpreter is interpreting it correctly. And if you want to stop and reiterate or change something, you don't have to try to backtrack through your G code buffer, but you can change things on the fly. And that's maybe not that exciting in the example of a milling machine, because milling machines do what they do pretty well. G code is pretty well developed for milling machines. But if you, for example, wanted to do something else with the G code, with your milling machine, so say you wanted to mill until you got to the red layer of a material and then switch, you could easily put a camera that would recognize between, say, the red layer and the green layer. But you couldn't necessarily have that interface with your G code. You would have to write a very complicated garble of control systems and software to be able to add that simple functionality to your machine. And so we're trying to get away from that. So here's with the modules, just to show you guys, here's a
got my A machines on the table, got my B machines in the drawer, got my A machines in the table.
So this one we made in 22 hours, including the water jetting of all of the side parts, including the soldering of the control system, including writing the software interface. Oh yeah, and it's a 4-axis hot wire cutter. Serious researcher, yeah. And so I guess I should also stress all of the machines that I'm showing you here, that I showed you up until now, are that we're developing kind of at MIT are all open source, and all of the mechanical design files and the control system, everything is available online if you go to the Machines That Make project website at MIT. And so I think that we are getting to a point where personal fabrication tools are becoming a thing that companies are thinking about too. Instead of having this model of the shop where you make things, having fabrication equipment be something that you imagine an individual having more like a power tool and less like a machining center. So this is Alon left the PhD program and started at a company making this handheld digital fabrication tool router. So it has this tape that you buy that you put down on the material that will recognize how far apart anything is, and it has this webcam on it with a small touchscreen interface, so that you can say, oh, I want to be cutting out a square here, or I want to cut out this complicated shape. And I don't know if any of you guys have ever used a handheld router before, but for example, cutting a straight line with a handheld router without a jig is pretty hard. And because you have gross global positioning with your hand, so you're the one dragging the entire contraption around, but then inside there, those two motors form a linkage that can do precision control of the router within it. So as long as you stay within a certain boundary area, it'll do the rest of the control for you. And a really powerful thing about this machine then is that this machine can make things that are much, much bigger than it is. Whereas in other cases, you go up to a machine and you make something that's smaller than that machine. But this machine applies the control through just these like custom inkjet printed masking tape parts. And so I think that's a really exciting direction for digital fabrication tools to go in. Also, I don't know if any of you guys ever used ShopBot routers. Anyone? Maybe. And so ShopBot is a woodworking router company that makes CNC table routers. And then at some point they were like, oh, we also actually want to do 5-axis milling of things because we need more figurines and stuff in our life. And so they actually prototyped this entire machine, the HandyBot, on a ShopBot as well. So they started using their tools to make more tools so that they could prototype different kinds of equipment that people might use in different contexts that aren't necessarily table routing. So this HandyBot, I actually used it once where I was at a dump, like a local garbage collection and sorting area, and they wanted more signage, and so you can hold this up against the side of a wall and then cut signs into the wall. It's kind of a more permanence of graffiti or something kind of tool, which I think is an exciting space of digital fabrication to explore. So without the capability to kind of iterate and design new digital fabrication tools, I really feel like the ecosystem can't grow. You don't want to just end up having people print things on the same 3D printers, because you're going to end up with a lot of stuff that looks the same. It's kind of the same way as if kids these days just have iPads and they are just downloading apps on iPads, and you can't write an iPad application on an iPad, or I guess if you jailbreak it, you can compile an iPad application on an iPad. But there's no way that you can interface with the technology that is that you're using, and so I think that's a really important thing to think about. And so I realize that not everyone hangs out at MIT in different kinds of Fab Lab-ish spaces with access to lots of tools where they can prototype. And so if you don't have access to that, what are other ways that you can build is something I've been thinking about. So what are other forms of access that you might have to precision manufacturing? So to answer this question, I went to Shenzhen, which is just outside of Hong Kong, and it's kind of a hotbed it's like right next to where Foxconn is. It's where people do a lot of electronics prototyping, and it's where people do there's a lot of small factories that you can get to do custom jobs for you. It's a really strange place. I thought it was quite odd. As a city, I think it's only maybe 2 years older than me, and I live in Boston, and Boston takes pride in having the oldest subway system in the world. Well, it's not something they should be proud of. It's a really bad subway system. It's way worse than New York. New York's pretty bad too. But in Shenzhen, they have a beautiful brand new subway system that they built in the last 8 years that is much more extensive than the Boston Greater Public Transport System. So it's a strange place where people build things really quickly, seemingly out of thin air. And you have these like strange tool and die shops where you come up and someone is eating like some kind of pastry, and then they ask you, do you want this kind of potentiometer? Oh, we don't have that one, but you can come back in 4 minutes and we'll have made it for you. There are these cell phone markets. So since a lot of cell phones get made there's this kind of liminal area around the cell phone markets that involves cell phone repair, and you can buy all these digitizers. If you want to buy, I don't really like iPads, so I'm sorry for harping on them. But if you just want, the display itself is really nice, right? It has a really high pixel count. And if you just want to buy the display and have your own little plug that you interface with it, you can buy one at this kind of, not sure if stolen or found, or for $60 you can get really nice screens and other parts. So here are all unsoldered ICs that would go in the iPhone 5. And here are a bunch of iPhone motherboards. And so if you wanted, I calculated approximately $12, you could make your own iPhone. It's not necessarily an easy thing to do, though, right? I mean, I would say that I'm very skilled at surface mount soldering, and the amount of time it would take me I think I would rather kill myself than solder an iPhone. And so access to precision tools doesn't necessarily mean anything unless you have the capability to use precision tools as well. And so again, with like the Moriseki that we looked at the beginning with the 5-axis control, since programming that is such a pain, even if you say, oh yeah, you're an artist and you want to use this tool, go ahead. You can't really expect people to invest 200 hours of software training into just being able to use the machine and then still think that creative things are going to come out. But in China, there are a lot of people that are learning about how to use precision fabrication tools. So this is Shenzhen University, which I think my understanding was that it was kind of more like a vocational school where people were learning how to use milling machines. So you can see on the desks next to these students, there are these small milling machines. And every student is learning about G-code, control, how to change their parts correctly, how to keep things clean. And then once they graduate from this class, they go to the next milling machine class, and they start using these larger milling machines. So there's a vast expertise there of how to make things. And I think there's a growing desire for understanding why you want to be making different things. So there's like an odd remixing that I observed that I wanted to talk to you guys about, of manufacturing things and things that you might desire in this space where people have learned how to manufacture things and have been doing them and have been doing that in different ways. So here's a phone I bought. The form factor might look kind of familiar. I paid about $17 for it. And here it is next to a real iPhone. And it's like a skinned Android OS that it's running. It has just kind of Chinese-specific apps on it, like WeChat and QQ. Unlike the iPhone, you can change its battery. It implements USB host. And I bet if you tried hard enough, you could get its processor opcodes. And so for some reason, someone in Shenzhen decided it would be a good idea to design this kind of mini cheap version of something that was being designed in California. I also X-rayed it to learn more about its origins, in which I found that in China, they really know a lot about manufacturing things really cheaply. There's no connectors. Connectors are expensive, I guess, but there's no connectors in there. They're just all sandwiched together, motherboards that have been soldered together. And so I think that, yeah, this object is so, this object is so hilarious to me because it kind of represents, we have the capability to make whatever we want. We have the engineering hours to make whatever we want, and so what we decided that we wanted was like a smaller, cheaper version of the iPhone. So if we could harness that expertise and put it into other things, how that could possibly be pretty cool. here's another cell phone we found. This is the Prashi. I'm pretty sure it's kind of more like the Ferrari logo, but yeah, it works great as a cell phone, and it came with like a gold chain, so you can wear it around your neck. And so, I guess the takeaway that I had from that was like that factories are really changing, and personal fabrication is growing, even at the level of workers in factories who think that they understand more about the market share that they might be able to interface with. You can say, hey, I think my friends might want to buy a gold Prashi cell phone, and so we're going to make it. And I think that kind of quick turnaround of prototyping is pretty exciting, but it's still not necessarily something that everyone can come along with. I don't know did you guys see the open source laptop that Bunny and Zobs designed? So it's a full, it's like a laptop that's based on an ARM core that they kickstarted. This is an X-ray that I did of it so that you could check to see if there were, in any of the closed chips, if there was any malware. I'm not really that worried about it, but we know for sure now that there isn't. And they kickstarted this. And they kickstarted this, or crowd supply, this laptop, so that they would be able to have a hacker's laptop that was kind of like the thing that they would use. So the specifications for it include things that you would expect in a laptop, like there's a certain amount of memory, you can use it, it boots Debian. But then there are these stretch goals that they added. So for example, it also has an add-on for software-defined radio. So want your own GSM base station? No problem. And I think that the cost of the laptop is not necessarily representative for its capabilities. I think the base laptop was maybe $2,000, which is more than people generally spend on computational devices right now. But I think like if you look at the engineering that went into it and the volumes that they're constructing at, I think that the way that I would see this project much more is this is an exploration. It's almost like journalism. This is an exploration where is it possible for people to make laptops that are completely open, that don't necessarily have a mass market, that are designed to be fully hackable? And how do you do that? So Bunny and Zobs have been working with manufacturers in China, the same places around Huaqing Bay Market where they have the kind of cheap cell phone parts that you can buy, to figure out if you can do this kind of small-scale manufacturing. And so can you circumvent large electronics producers to make things that maybe you're more personally interested in? I think it's a pretty cool project. So with this new kind of you have this kind of new possibility of making stuff where you have access as an individual to material, you have access as an individual to engineering tools, and you have access as an individual to manufacturing equipment. I think that sourcing is one of the big problems that you encounter, and so I guess that's one of the reasons that I was pretty interested in going to China and figuring out where can you go somewhere, find a street market, and buy a chip, not Radio Shack anymore, or maybe Radio Shack a little bit, but mostly you go to Radio Shack and you're going to buy an 8-bit microcontroller that is going to be able to run, not a whole. It's not going to be you're not going to replace a device that you're using on a daily basis with a 8-bit microcontroller. And so I don't know if you guys have heard of this website Taobao, but it's kind of a portal to start interfacing with small factories in China. You can order things just off of Taobao, or you can start communicating with sellers on Taobao who then help you manufacture things. So for example, for that workshop that we taught, one of the things that I wanted, on the right you can see, or maybe you can almost not see, but on the right I wanted a custom lead screw motor assembly with a specific kind of lead screw nut so that I would be able to move things around in a certain way. And so I made a drawing specification and sent it to a manufacturer in China, and then was able, for the cost of $17, to get these precision integrated lead screw motors with wear compensating lead screw nuts from China, which I was very, very excited about, because the equivalent cost if you would buy the components off of the shelf would be around $150. So making more
more machines that are more suitable for whatever it is whatever the purpose is that you want to make machines for. So that's pretty much all I wanted to talk to you guys about. Thanks a lot for coming to my talk, even though Thomas Drake is talking right over there, guys. And if you have any questions, I actually have some time, so you can ask them. Yes? Oh yeah, that was horrible. The DARPA Red Balloon Challenge. So we took a lot of photos of the balloons, and we changed their EXIF data, and we posted them on different places. And I definitely think we threw the trail. We threw some people off the trail of finding it, but 10 hours later, there's another group at MIT who are lovely people, and they created this created this social platform where you could invite all of your friends, and they could invite their friends, and they could invite their friends. And if one of your friends found a balloon, they would get $1,000, and you would get $500 for referring them, and then that you would get $250 for referring them, et cetera, et cetera. So they created this massive, unregulated experiment where they collected huge amounts of information about people's personal networks. And people all just kind of did it. I was really pissed about that because I was like, why are you just giving up all the people that you know? That's not something that you just want to give to a researcher without knowing what their research agenda is. But it took them, using that model, it took them 9 hours to win the balloon challenge. And so they won the $40,000, which then they had to pay out into this massive unregulated human experiment. And then they were invited to speak at the Tonight Show or something, and they came down to the lab and they said, oh, have you heard of us? We won the Red Balloon Challenge, and now we're going to be on the Today Show or the Tonight Show, I forget exactly. And they're like, good. And we want to make sure that everybody really knows that we're scientists, so we're wondering if you could lend us a lab coat. And then I said, well, I really take issue with the way that you've approached this experiment, and I would like you to know that I'm extremely cross with you. And they said, so will you lend us a lab coat? So then I lent them a lab coat, and I wrote a really snarky blog post about it. And I think I'm now featured in their presentation about this wonderful, social connection mining experiment as the technological Luddite and the person that is opposing change, because obviously they're on the path of smartness, and if you're not part of smart connected devices, you must be dumb. Does anyone else have any other questions? I can tell you all about how to make network control systems. Okay, instead of G-code, so there's, let me go back to this pyramid. We're using something called Gestalt, which we wrote ourselves. Gotta go back really far. So the nodes individually are running embedded C to interpret, so the nodes that control one sensor or one actuator each are running embedded C, and that embedded C listens to a bus network protocol that we're calling Fab Bus, which runs both over RS-485 and over other communication, depending on what communication networks your machine might already have access to. There's different nodes written for them. So you can write an application. Say you have a browser. We have one browser-based application that'll listen for things from the browser and then send them as packets over this Fab Bus. And then each individual node will interpret those commands, and you can write those commands yourself. So instead of saying, oh, G92.000, machine goes home, you can just write a function that says home, and then each node on the network knows where its machine home is, and we'll just move back to that location. But one thing that that we didn't necessarily want to do was tell everyone that was using G-code that they couldn't use G-code anymore. So if you want, you can stream G-code over the Fab Bus as well, and it'll still, as long as you've specified what each distance is in G-code, it'll still move to the right places. But yeah, the system that we're using is called Gestalt, and we have it up on GitHub if you want to take a look at it. Yes.
it's wonderful what you do, and I hope it all works, but it's still too complicated. I don't know enough about how to use or even conceive of these personal machines that they can use.
Right.
So how am I going to get educated about that? How can I bring that to children in high school?
Yeah, I think that's it's a really good point, and I fully agree with you. One of the things that I guess I find kind of frustrating about spaces like MIT is that people always act like the thing that you're learning is the technology, or the thing that you're like this. If you go to a maker space, the thing that you're there for is the 3D printer. The 3D printer is really quite useless unless there's someone there that can help you learn about the 3D printer. And maybe you want to learn about it through the internet, or maybe you want to learn about it from a book. But at the end, like you have to find some way that you can interface with someone else to learn about it. So I guess there's two things that I'm trying to do to address that problem. Number one is you can talk to me, for example, and hopefully people like me. So like seek out other people in your community that are excited about digital fabrication, and then I guess one of the things that we're trying to do with the Fab Bus and these control system networks is to make it much easier to make machines. And so not just by teaching people how to build machines, but also by changing the tools with which they can build machines. So for example, in September, we're going to have some architecture students at the University of Kansas play around with building machine systems from the networked machine controllers. But I realize that's maybe not a very satisfactory personal answer to your question personally. But yeah.
Well, I want to hook up to a Raspberry Pi.
Yeah, that's a great idea.
What is it, and how do I start conceiving of it? Is this stuff available?
Which stuff? The network node?
Digital.
So the boards, the whole machine, or just the control system nodes? So all of the design files are online, but you can't buy the boards pre-assembled, but the design files for that are online, so you could buy the board and then solder it yourself, which I realize is not a very satisfactory answer either. Maybe if you could wait for like a year, maybe one day I'll graduate and I'm going to work much harder on it. Yeah. Okay. Yeah, I will. Yes.
I was just wondering, so I couldn't understand kind of like the position against each other from an obfuscation standpoint, but I was wondering if you could talk about why you think that very complete language
is a good thing.
I think that we would kind of like want stupid output formats to stay stupid, and a good example of that is PDF and Stuxnet.
Right.
So why do you think that we need a complete machine control?
Well, I guess if you're worried about security of your machine, and then it's nice that G code isn't a Turing complete language, because you can't execute code on it. But I think that if I have this photograph I took of a friend of mine who's using a 7-axis robot arm, and he's using it to cut styrofoam surfaces. And the styrofoam surfaces have very complicated topology. It's like a full non-zero Gaussian curvature that he's trying to approximate with swoops back and forth. And the swoop motion that goes back and forth is fine. He can program that in G code and have the KUKA robot arm interpret the coordinates that it's sending to it. But he's standing next to the robot, and this is what I think is striking about the photograph, is he's standing next to the robot, and he's controlling the temperature of the hot arm that's cutting the styrofoam by he hooked it up to a surge protector, and he has the surge protector in his hand, and he's flipping the switch off and on with his thumb. And so he's standing next to the machine, and the easiest way for him to interface with the machine system and change something about the machine is to put a hard stop in it and control it by turning it off and on with his thumb. Thumbs are pretty expensive, and that's like it's a frustrating. You could get around it with enough if you wrote an embedded controller that took something that you decided to specify within the G code as on and off, add a transistor to add a transistor that would turn off and on the hot wire for you and recompile your controller box firmware, put that on the controller box, and then talk to that from some software that you custom wrote, then yes, you could do that. However, I think it's a waste of time.
It sounds like more like what you're after. It's like syntactic sugar. It sounds like you're after like more syntactic.
I would say it's more ease of use. If I don't want someone to come up and say, I want to build something, and I don't have time to like hack all of these existing systems. This is going to take me too long. I'm going to work on something else that's not fabrication engineering. I don't know, do you guys know Travis Goodspeed, the guy who organized NeighborCon? So he did that thing with a satellite, all right, where he had a satellite dish that he was pointing around in different places. And so instead of using the control box that he had in the satellite dish, which probably would listen to G-code, he kind of repurposed the internals of an egg bot, so the little doohickey machine that draws on Easter eggs, because that was the easiest way for him to interface with that system. And he happens to be a very tenacious kind of guy who's okay with taking out an entire control system, writing firmware for a new control system and hooking it up to a satellite dish and then looking at different kinds of stars. But I think that the world would be a better place if more people could do things like Travis Goodspeed. Yes.
So earlier you were talking about, right now you're talking about how it's quite controlled to do these kind of machine making things. In Shenzhen, obviously they have a lot of wealth of people making approach phones and whatever. But obviously it's probably still quite difficult for them. They have like advantages of being right next to manufacturing. Do you think like what do you think? Obviously, America is not really right next to manufacturing anymore. Do you think like just making it easier is enough will allow kind of this dynamic, making your own personal thing, or is it like gonna still be too practical to like get everything shipped because you're not right next to a factory that can make very specialized things?
I think that because of portals like Taobao and other kind of internet mediary interfaces, it's getting a lot easier to buy things. So before I bought those motors in Shenzhen, I also buy motors from Hayden Kirk Switch Co., which is in Connecticut, and the lead times for their motors are actually much longer than the lead times including shipping for the motors that you order from Shenzhen. So I think that there's like an argument that you can make that we live in a cosmopolitan society where we have rapid access to different places in the world that have different pockets of expertise. I realize that it also is maybe not a super, if you're concerned about the American economy, perhaps you don't want things to be manufactured abroad. But for me, it's also just a question of where can you get tools, materials, and parts that are to the specification that you need at a price that you can afford in the timeline that you have available to you. So yeah, I think it's complicated, and I think that moving closer to working together with small-scale manufacturers in China is definitely a direction I think that we're going in, and I'm pretty excited about it. Maybe Obama's not so excited about it. Yeah. Okay, so that was it. So long, y'all.